today we're going to begin talking about a concept that's somewhat difficult called related rates, and we'll spend several days on this in class. Just remember that you can rewind, pause to write down things that I say or to listen to me again, so don't be afraid of doing that. Related rates are when something is moving with respect to time. So like a ladder is sliding down a building, or you're blowing up a balloon, or a car is driving along a wall, or so many different things. You're filling something with water or emptying something of water, or something's evaporating, that sort of stuff. So let's look at one simple example first. It says air is being pumped into a spherical balloon so that its volume increases at a rate of 100 centimeters cubed per second. How fast is the radius of the balloon increasing when the diameter is 50? First thing you should do, and these 5 steps I give you are advice. You don't necessarily have to show them all every time, but you will at least think about it. So, draw a balloon. What did they tell us? Well, they told us the volume increases at a rate of 100 centimeters cubed per second. It's the volume, which means it's a rate of change, so it's the derivative of the volume in terms of time. It's 100 centimeters cubed per second. And they tell us that the diameter is 50. We know some stuff about balloons, and typically the unit you need to find volume or surface area is the radius, so we can think about that while we're here also. So they want to know how fast is the radius of the balloon increasing when the diameter is 50. They want to know how the radius is changing, so they want us to find dr dt, the rate of change of the radius with respect to time. So, what's our equation for volume of a sphere? Well, volume of a sphere is found by 4/3 pi r cubed. Now, in order to solve this problem, we can't plug anything in unless it is constant all the time. But as you're blowing up a balloon, the radius is changing, the volume is changing, 4/3 pi are constants, so to solve this, we need to derive in terms of time. So we're deriving implicitly. Derivative of v will be dv dt. Derivative of 4/3 pi r cubed, multiply by the 3 out front to get a 4, pi r squared, dr dt. Don't forget the chain rule when deriving implicitly. So, now let's plug in what we know. We know dv dt is 100. 4 pi is a constant, and r is 25. Then we need to solve for dr dt. Go ahead, do some algebra, solve for dr dt. We will talk about these solutions tomorrow. Here's another example. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So I'm going to label these X, Y, and Z. And let's talk about what we know. It says the bottom of the ladder slides down the wall. Oh, the bottom of the ladder slides away from the wall at 1 foot per second. So this X is growing at 1 foot per second, which means dx dt equals 1 foot per second. Says how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall. So we know x is 6 feet. Now, the last thing we know is that z is 10. And you might want to make a note that the length of the ladder isn't changing. So, it's going to stay the same all the time. It says, what's the unknown? We're trying to find how fast is the top of the ladder sliding down on the wall when the bottom of the ladder is 6 feet from the wall. Now, let's talk about this. That means we're finding dy dt. If it is getting smaller, your answer should come out as a negative value. So, hopefully, when we're all done, we get a negative value for our dy dt. So, do we have an equation that relates all of this stuff? We do. Pythagorean theorem. Is there anything in the Pythagorean theorem that never changes? Does x, y, or z ever, do any of them have the property that they are always that value? And they do. Z is always 10, so x squared plus y squared equals 100. Now, from here, we need to derive 2x dx dt plus 2y dy dt will equal 0. Now, at this point, we need to plug in what we know. We know the 2, we know x is 6, we know dx dt is 1, I believe. Yes. We don't know y. We're trying to find dy dt. Can we find y if we know x is 6 and the latter is 10 at the time we're talking about? Yeah. So, let's do some magic. We know x squared plus y squared equals 10 squared. X is 6. We find out that y is 8. So, plug in 8. As we continue, we get 12 plus 16 dy dt equals 0. So dy dt equals negative 12 16, which is negative 3/4. And our label is feet dy dt. So y is measured in feet. T, I believe, was measured in seconds. So feet per second is our answer. And it should be negative because it is getting smaller. Finally, a water tank. Third type of example, a water tank has the shape of an inverted circular cone with a base, radius 2, and a height of 4. So, we're talking about this cone. Radius is 2, height is 4, and we need to figure out what else we know. So, what quantities are given for the problem? It says if water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So, dV dt would be our 2 meters cubed per minute. Put that up here. That's a quantity we know. We also know that H is 3 meters. And we're trying to find the rate at which the water level is rising. That would be how the height is changing with respect to time. Now, we need an equation to relate these quantities. Volume of a cone is 1/3 pi r squared h. And is there anything that never changes? The volume is changing. The radius is going to change as the water gets higher. The height is going to change as more water is being pumped in. So, everything changes. But we only really know stuff about H. What we also know is that this is a cone. So, let's talk about half of a slice of this cone for a second. We know it's 2 and 4 in the cone, but we don't know how tall the water is. So the water is R and H. Now, we can use this proportion because those triangles are proportional to come up with a formula for R. So, R over H equals 2 over 4, meaning 4R equals 2H, and R is equal to H over 2. So if R is H over 2, that's always going to be true because these are proportional. I'm going to plug that in for R and simplify this a little bit. So really, V is equal to, square your 2 would be a 4. 1/3 times 1/4 is 1. 1/12 pi, and then h squared times h is h cubed. From here, I no longer need the product rule. I can find dv dt easily to get 1/4 pi h squared. Go ahead and plug in what you know. You know dv dt. Oh, dh dt, sorry about that, chain rule. And you know h. Plug in those values and solve for the dh dt that we're trying to find, and we'll finish talking about this tomorrow.